Hello. Yeah. So this is Kiran Gaikwad, and I'll be taking this power electronics tutorials and something a little about me. I'm doing my master's in electrical engineering from Sardar Patel College of Engineering, Mumbai, India. I'm specializing in power electronics and power systems. So I think it is necessary to understand power electronics through simulations, and that is why I have started with this YouTube channel, and let's see how it goes. So let's start. So what is power electronics? Uh, this was the question which enticed me when I started with my ME, and after learning about it through these 2 semesters, I finally got to understand a fair bit about it. So it is associated with efficient conversion, control, and conditioning of electric power. So what is efficient conversion, and why do we require conversion? So in usual power system or the conventional power system, there are generators which work on thermal, nuclear, hydro, and they produce AC power at constant frequency and constant voltage. But a lot of applications for the users we require not AC but DC power, or an AC power at a different frequency. How can we achieve it? The answer is power electronics and about control. So if you're an electrical student, you would know that we have a variety of motors: induction motor, the DC motor, the synchronous motor, stepper motors, and nowadays brushless DC motors. And all of these require control. And control is possible only through power electronic devices. And then there is problems regarding transmission of electric power, where we have started utilize fax devices, and all these fax devices are possible due to power electronics, where we condition the power. Okay, so let's start. Why is it required? I explained a fair bit about it. Let's go to the slide. To provide the type of electrical power required at the consumer end. So if we require AC power, we get directly from the grid. If we require DC power, we have to convert the AC into DC. And this is only possible through power electronics. Create energy efficient and high performance electric motor drives. So in process industries, it is of utmost importance that motors should be controlled very efficiently, and they should give a very high performance. This is only possible using power electronic devices to control the motors. Then there is HVDC power transmission. HVDC power transmission has 2 converter stations at both the ends, and one acts as a rectifier, converts AC into a DC. The DC power flows over the power transmission system, and then at the other end, the converter converts the DC power into AC power. It has a lot of advantages over the AC power system when considered at long range power transmission. Then we come to non-conventional energy sources like solar and wind. So if we have to derive electric power from solar, we have solar photovoltaic cells, but these produce DC power. If we have to transmit this power into our grid, we have to convert it into AC power. And it is only possible by using inverters, and that is power electronics. And there is wind energy. A lot of variety of motors are used, or machines are used rather, to convert the wind energy into electrical energy. And to convert this AC energy into a fixed voltage and a fixed frequency so that it can be transferred over the transmission line, we again require power electronics. So, power electronics is required everywhere throughout from generation to transmission to distribution, and most importantly at consumer ends. Okay, so what makes this possible? What is the device that makes this possible? And the key component is nothing but a switching power converter, or just a switch. This switching power converter is at the heart of the power electronic system. So the family of power electronic switches, there are a lot of variety of power electronic switches. Power diodes, silicon controlled rectifiers, thyristors, get turn off thyristor, the triacs, bipolar transistor, power MOSFET, insulated gate bipolar transistor, MOS controlled transistor, integrated gate commutator thyristor. In subsequent lectures, we will try to understand the physical characteristics of each of these devices and see how we can apply these devices to create schemes so that we can control power. That is the sole aim of power electronics, to be able to control power in the way, the form, the amount we require. Okay, let's go ahead. So this is a simple schematic of a power electronic system. There is the source which feeds the power system. Then there is the power processor. This power processor is the power electronic system which converts the input power into the desired output power, and it is supplied to the load. What is this? This is a reference, it's a feedback loop. It compares what kind of output we are getting, and then there are the controllers which then control the power electronic elements, and we get the desired output. This is a simple feedback control loop, and it is always used in high performance power electronic systems. Okay, let's go ahead. So types of power electronic conversions. There are four types. First one, rectification, and it's converting a fixed amplitude, fixed frequency AC source to a variable DC source, where it is used. Have you seen your mobile chargers? It does the same. Your mobile battery requires DC power. We plug the charger into the switchboard, which provides AC power. The charger converts the AC into the DC, and your mobile gets charged. And the second category is inversion. It is converting a fixed DC source to a variable frequency, variable amplitude AC. Where is it used? Inverters are used in backup power supplies, where you have batteries, you store electrical energy into the batteries, and when you're out of power in countries like India, you have an inverter that converts the DC power from the batteries into AC power. And of course, at 50 hertz, on inverters actually, in theory, can produce electric power at any frequency. We'll see in the future lectures. Then there is chopping, that is DC to DC conversion, converting a fixed DC source to a variable magnitude DC source. Why do we require this? Control of DC motors, maybe? Yeah, yes. Then there is the fourth type, cycloconversion. It's converting a fixed frequency, fixed amplitude AC source to a variable frequency and variable amplitude AC source. We'll see this in future lectures. Need for power electronics simulations. Actually, when I was in my undergraduates, I wasn't familiar with simulation tools, and we studied power electronics in the form of equations and graphs. It was quite difficult, and I almost failed that subject during my undergraduates. But when I came to the ME course, I started using simulation tools, and it is a really great way to understand the concepts of the subject. We can create any kind of a power electronic system on our laptops inside the simulation environment and then analyze it, see how it works. Working in such an interactive environment is fun, hence the subject does not become a graphical and mathematical burden. Most importantly, we can design and analyze the circuits without having to create a costly prototype. So if you have to design some kind of a power electronic system, you wouldn't go directly to the store and buy those switches and hardwire them. You will first go to the simulation lab. You'll simulate what you want to do. You'll analyze it. And then, once your design is perfect, you'll go and buy your components and create a prototype. And that way you are not going to mess up with the costly electronics. Also, the simulation environment is like a portable power electronic lab in your laptop. Okay? So I'll try to teach you power electronic simulations in MATLAB, Simulink. Okay, let's go further. So what are the different kinds of applications for power electronic simulations? Firstly, which I use, is MATLAB and Simulink. It has a really good toolbox, the SimPower systems. It makes your life very easy. And there is PSCAD, this Power Systems Computer Aided Design. It is created by Manitoba HVDC Research. Then there is Sabre by Synopsys and PSIM by PowerSim. But the focus of our course or this tutorial lectures would be MATLAB and Simulink because it is quite easy and it is really quite useful to learn even MATLAB as a programming language. Okay? Okay. Okay, so the course focus would be the study of power electronic devices, study of different power conversion schemes, and use of MATLAB and Simulink as a simulation tool for learning and understanding power electronics in a better way. Okay? See you soon in our subsequent lectures. Thank you.